Okay, so this is a reaction between sodium hydrogen carbonate over here and tartaric acid there. Now these are two components, two reactants within baking powder. Once they dissolve in water, they react, and these are the products they produce. Most usefully is the carbon dioxide, because that's what produces the bubbles, the gas, in order to make cakes rise and so on. So it's saying that a reaction is carried out using 12.9 grams of sodium hydrogen carbonate and 14.1 grams of tartaric acid. It says the sodium hydrogen carbonate is a limiting reactant. So let's just color that now. And I'm going to color it up there as well. And this one here. So that if that's the limiting reactant, that means that's the one that runs out. So all of the tartaric acid is used up. And that would mean that the sodium hydrogen carbonate is in excess. So the 12.9 grams is more than enough to react with the 14.1 grams of tartaric acid. So we don't know how much of the sodium hydrogen carbonate reacts with the 14.1 grams of tartaric acid, but we know it's less than 14.1 grams because it's in excess, because the other one is the limiting reactant. And so you can see here that it actually says calculate the mass of tartaric acid that will be left over once the reaction is complete. So there you see we will have some left over. So 14.1 grams is not going to be used at the beginning of this moles question. You need to first work out the mass of tartaric acid that would react with 12.9 grams of sodium hydrogen carbonate. That part of the question is that you need to work out, and that's the sort of standard moles question. So you need to realize that the first thing I need to do is to work out what mass of tartaric acid would react with 12.9 grams of sodium hydrogen carbonate. Now that, and then it's kind of the standard sort of moles question stages. So you would turn this into moles using the molar mass down here. And then once you've got the number of moles, you would use the balanced equation to identify the amount of moles of tartaric acid. You can see it's 2 to 1. So whatever amount of moles of sodium hydrogen carbonate we're going to get, we're going to need half as many of the tartaric acid. And after you've done that, you would have then worked out the amount of moles of tartaric acid, and then turned that into mass. And now we've got the mass of tartaric acid. What we would do then is realize, well, hopefully we're going to find that is less than 14.1. I'll go through these stages in a moment, but you can see that we eventually worked it out to be 11.55. And so you then do 14.1 minus 11.55. So let's go through these stages more carefully then. The first thing, as I said, was to work out the moles of 12.9 grams of sodium hydrogen carbonate. The molar mass of sodium hydrogen carbonate is 84 grams, which means that if I had 1 mole, it would be 84 grams. So 12.9 is a fraction of 84, and that fraction would be the amount of moles. So we do 12.9 divided by 84, and that gives us the amount of moles of the sodium hydrogen carbonate. So now we've got the moles of sodium hydrogen carbonate. We go up to the balanced equation, and we see it's 2 to 1. So whatever amount of this we'd get half as many in terms of moles of the tartaric acid. So we take 0.154 and we would divide it by 2, which is what we've done over here. And we get 0.077 moles. And this is the tartaric acid. Okay, so let's make sure we write down what we're doing there. This is, need a different pen. So this is of the tartaric acid. And this one here is, it says over here anyway, we've got a title there, but these when you're doing multiple moles and multiple masses, it can get confusing. You would then convert the moles, which so 0.077, to the mass. That's the molar mass of tartaric acid this time from here. So 1 mole would be 150 grams. This is 0.077 moles. So you multiply it by the 150, you'd give that many. And let's make sure we use unit grams. And then you would, to work out what what's left over, we've got the amount that we were given minus the amount that we have worked out would have reacted. And then the leftover amount would be the 2.55 grams. Does that make sense?